In this ACT video, we're going to take a look at operations with radicals. More specifically, we're going to look at adding expressions with radicals and subtracting expressions, which are going to be very similar. So let's take a look at our first example. And what you want to think about when you have to add and subtract radicals is think about like terms. With like terms, we had the same variables with the same exponents. For example, we may have seen in algebra 3x plus 7x. Those are like terms because they have the same variables with the same exponents. So we just added the coefficients, 7 plus 3, giving us 10x. When we add or subtract radicals, you're doing the same thing. 3 square roots of 5 and 7 square roots of 5. Because these both have the square root of 5 attached, makes these like terms. So we just need to add the coefficients. 3 plus 7 gives us 10 square roots of 5. Then you just want to make sure everything's completely simplified. And by that, mostly just the radical piece. So 5, the radicand, has only factors of 1 and 5. And so it has no perfect square factors. Therefore, we know this is completely simplified. Let's take a look at one where you have to do a little bit more work. Looking at this one, 9 square roots of 45 plus 11 square roots of 75 doesn't look like these are like terms. But my two radicands, 48 and 75, look pretty big. So I'm thinking I have a little bit of work I need to do on the front end before I try to add these. So let's take the square root of 48. Let's go over here to the margin. And if we want to simplify this, which we reviewed in a previous video, we know that we can split this up into the square root of 3 times the square root of 16. And that works well for us because the square root of 16 is a perfect square, which is 4, and then we just bring down the square root of 3. So the square root of 48 simplifies to 4 square roots of 3. So what you'll want to do is you'll want to bring the 9 down. You want to open up some parentheses, and we're going to replace the square root of 48 with 4 square roots of 3. Then we just need to multiply the 9 and the 4. That gives us 36 square roots of 3. So that term's now completely simplified. Let's bring our plus sign down. Let's bring our 11 down. Then let's also go to the margin here and let's simplify the square root of 75. So right over here, let's take the square root of 75, which makes me think of 75 cents. And so I know that I can factor this as the square root of 3 times the square root of 25. Remember, you're looking for two factors so that one of the factors is a perfect square. Hopefully, the biggest perfect square factor. All right, so square root of 25 is 5, and bring down the square root of 3. So now we're going to go back to our problem, and we're going to replace the square root of 75 with 5 square roots of 3. So open up your parentheses, that's 5 square roots of 3. Then you're going to want to multiply 11 times 5, which is 55, square roots of 3. Then all we need to do now are add the coefficients because these are like terms, 36 square roots of 3 plus 55 square roots of 3. So add 36 plus 55, and that gives us 91 square roots of 3. So it's very much so like combining like terms, except you might have to do a little front end work by simplifying the radical. Let's do one subtraction. It works the same way, except you're going to subtract the coefficients. So looking here, we have 4 square roots of 50 minus 12 square roots of 72. At first glance, these don't look like terms. However, 50 is an awfully big number, and so is 72. So I'm going to guess we can simplify these and make this where we have two like terms. Let's take the square root of 50, go into the margin. Our two factors of 50 that we want to use. We want a perfect square factor, so we're going to do square root of 2 times square root of 25. Square root of 25 is a perfect square, so we have 5 square roots of 2. So bring down your 4, open up your parentheses, and we're replacing the square root of 50 with 5 square roots of 2. Then we're going to multiply the 4 and the 5, giving us 20 square roots of 2. Minus, bring the 12 down. We're going to go to the margin and simplify the square root of 72. You might be tempted to use 8 and 9 as your factors of 72, which is good because 9 is a perfect square, but we have a better set of factors. We can use the square root of 2 times the square root of 36. 36 is the biggest perfect square factor. The square root of 36 is 6. Bring down the square root of 2. So we'll replace the square root of 72 with 6 square roots of 2. Multiply our coefficients, and let's bring that minus sign down. And then 12 times 6 gives us 72 square roots of 2. Now we definitely have like terms because they both have a square root of 2 in there. So we're going to do 20 minus 72, which gives us negative 52 square roots of 2. And we're done.